Okay, so this is an exam question. Yeah, it carried 11 marks. So challenging exam question from linear momentum. So it carried 11 marks. So it reads: a 2 kg ball moving at 10 meters per second makes an off-center collision with a 3 kg ball that is initially at rest. After the collision, the 2 kg ball is deflected at an angle of 30 degrees from its original direction of motion, and the 3 kg ball is moving at 4 meters per second. Find the speed of the 2 kg ball and the direction of the 3 kg ball after the collision. So to solve this question, it's so important to have a sketch. You make sure that you sketch the diagram. You just make your own simple sketch so that it's very easy to refer to. That's how we do with most of the physics questions. So let's have, this is the first ball, which has M1. It collides with this ball, the second ball, that is at rest. Now this is before they collide. So before collision. And before collision, there's nothing like they were at an angle. They were horizontal. Yeah, so meaning that they are in the x-axis. Yeah, and remember, let's assume M1 was moving to the right. So now after they collide, they are going to make this M1 makes an off-center. This is M1 and this is M2. It comes here. So now they collide, they both deflect from this original direction. They were supposed to go this direction, but after they collide, this one goes this side, this other one goes the other side. It only makes sense if this one collides with M2, then if this one can go up, then it only makes sense that this one will go down. That's why I've done the sketch like this. Now they are saying a 2 kg ball. So let's have, this is 2 kg, this is 3 kg. So now, and this first ball is moving at 10 meters per second. So and the second ball with this 3 kg ball was at rest. So this was at rest, meaning that initial velocity was 0. So after the collision, the 2 kg ball is deflected at an angle of 30. So 30 is the same as pi over 6. So this first ball is deflected at 30 degrees. The 2 kg ball is deflected at 30 degrees from its original direction of motion. This is the original direction of motion. So this is the x-axis. So above the positive x-axis, we have an angle of 30 degrees. And the 3 kg ball is moving at 4 meters per second. So we are told that after collision, that is V2 final, we are given is 4 meters per second. That is what we are told. So after collision, this one moves at 4 meters per second. So we are going to find this angle here, which we don't know. We need to find the angle. It's not always in some books they say they make an angle of 90. If you add this 30 plus theta, the answer is 90. No, sometimes it's not like that. In reality, that doesn't apply. It only applies to a certain situation, but not to all situations. So that's why it's important to know how to find the theta, not just by subtracting 30 from 90. Yeah. So now we need to find we need to resolve, to start solving this question, we need to resolve the final velocity of this is 4. We need to resolve this 4 into its components on the second ball after collision. So we are going to call it V2 final Y. We are going to call this one V2 final X. Yeah, so same applies to this one. We need to resolve this, the final velocity here into its components, which we don't know, V1 final Y. Also here to have V1 final X. So now, after having this information, it's important to remember the law of conservation of linear momentum. So we are going to have summation of momentum before collision equals to summation of momentum that is after collision. So this is the law that we are going to use to solve this question. So we are going to write this law, and then we see what we can do from there. So summation of momentum, we have two objects here, object 1 and object 2. So this object here has its own momentum, and this object here has its own momentum. So what we are going to do is we are going to find momentum of the first ball. So this is momentum of the first ball, which is M1 V1. You get? So also we need to find momentum of the second ball. So P2, momentum of the second ball, we know that momentum equals to mass times the velocity. So we are going to have mass 2 times V2. So this is momentum of the first ball, and this is momentum of the second ball. So now we can just add the momentum. Now we found the momentum before they collide. So what was its momentum before it collides with this one? So we are going to add the two, that is summation. So we're going to have M1 V1 plus M2 V2. Now after they collide, we are going to say initial, also here initial. So the same thing we've written this side, we are going to repeat it the other side. So we are going to have M1 momentum after they collide, now PF, M1 V1 final after they collide, plus M2 V2 final. So this is the equation that we have now. So now it's important to know that the kind of linear momentum problem we are looking at is called glancing collision. Glancing collision, meaning there is an angle here. Yeah, when they collided, these two objects are deflected. They deflected off the center. So that means glancing collision at an angle. That's glancing collision. So now the same law that we have written here, we are going to resolve this one into two components: the x dimension, and the y dimension. So let's find momentum in the x direction. So here we're just going to add x to show that we are now looking at momentum in the x direction. So now we are going to say, now we have M1. Remember, before they collided, before collision this side, they were not at an angle, at any angle. So the same velocity, we are going to put it to get it like this, no resolving of this 10 meters per second. So we are going to multiply 2 times 10, that is for the momentum of the first ball, 2 kg ball before it collides. So we are going to have 2 times 10, then plus. Now remember, the second ball was at rest, so that means 0 velocity times the mass, it will give us 0. This equals to after they collide, we have m1, which we have 2 times v1 final x. We don't know what this v1 final x is, so we're going to say v1 final x plus m2. M2 we have, it's 3 kg, so 3 times v2 final x. So remember, we need to know what v2 is and what v1 is. Yeah. So now we can just simplify things here. We have 2 times 10, we are going to have 20 equals to plus 0, which is just 20, equals to 2 v1 final x plus 3 v2 final x. So now here we need to note something here. From this diagram here, you can see that v1 final x, what is this is the x, this is the same as this. So mean that now this velocity v1 we are not given, but we can find the component of this v1, which is in the x, it is cut, this side is cut, so it's going to have v1 after collision times cos 30. So what I'm saying is v1 final x is the same as in the x direction is the same as v1 prime. This prime, it means after collision, final velocity, that's what it means. So cos what? Cos 30. Cos 30. And meaning that v2, what is v2 final x? You can pause the video and just guess. What is v2 final x? Here, for this one, this is v2. After they collide, this is v2. So what is v2 final x? So v2 final x is going to give us v2, which we are given in this case is 4, v2 cos theta, which we don't know. This is the information that we have. Now the same information here, we can just plug it in here so that we simplify. So 20 equals to 2 times v1 final x, which is times v1 prime cos 30, plus 3 here, 3 times v2 final x, but in this case v2 is this one. But remember, we are given v2. The question was saying, after collision, the 3 kg ball is moving at 4 meters per second. So we are given final velocity of the second ball after collision, which is 4 times cos theta, which we are looking for. Now here we can simplify. We can have 20 equals to, what is cos 30? So we can have 2 times v1 collision, v1 prime cos 30. Remember, what is cos 30? 30 is a special angle. So if you draw this kawan, in case we don't have a calculator, if you draw this kawan, here we're going to have 30, here we are going to have 60. So you are standing here, so cos is adjacent over hypotenuse. So what is cos 30? It's adjacent, which is the square root of 3 over hypotenuse, which is 2. Here it's 1, if you get. So cos 30 simply means square root of 3 divided by 2. That is cos 30. So plus 3 times 4, we are going to have 12 cos theta, which we are looking for. I hope you are following up to now. So if you multiply 2 times the square root of 3 over 2, it's going to give you 20 equals to square root of 3 v1 prime plus 12 cos theta there. So now this is our first equation that you have. So this is our first equation. Remember how we need to know what is the angle so that we find v1. The question is saying find the speed of the 2 kg, mean that find the speed v1 and the direction of the second ball. That's what they are saying. So mean that we need to find this one and this v1. That's our goal. So we need to know what is this and what is this. That is our goal. So the first equation, where is it going to come from? Remember, we wrote this law of linear momentum, conservation momentum, in the x direction. Now we need to write this in the y direction. So what we are going to do, in, let's say, y direction. So in the y direction, we are also going just to write the same one, the same law. We are going to write it, to rewrite it. So we are going to have m1 v1 initial, now initial y, you get. Here we are saying initial x, but now we are in the y axis. So m2 v2 initial y equals to m1 v1 final y, you get, plus m2 v2 final y. So this is the law of conservation of linear momentum in the y direction. So from here we can just interpret some things. So let's consider these two balls. This one, was it going in the x direction or y direction? Since this ball is not going up or down, so that means it has no y momentum, you get, because the ball was not going up or down. It was just going from left to right or right to left, horizontal. So this means ball 1, 2 kg and 3 kg, they only have x momentum. Yeah, they just possess momentum in the x direction. So both balls were not moving up or down. So that means they have 0 momentum in the y direction. So 0 plus 0. So that's what you're going to do before they collide. Before they collide, they had no momentum in the y. So equals to, now after they collide, as you can see, after they collided, there is momentum in the y for this ball, and also there is momentum in the y for the first ball. So that means we are going to have m1. Now m1 we are given is 2 times v1 final y, plus m2 we are given is 3 v2 final y. So this is what we have. So we can just simplify it. We are going to have 0 plus 0, that is 0, equals to 2v final y plus 3v2 final y. Now after we do this, we can just take this the other side. So we're just going to write it here because I've run out of space. So we have 2v1 final. I have 2v1 final. Now I have negative 2v1 final y equals to, so taking it the other side, negative 2v1 final plus 3v2 final y plus, so plus c equals to 3v2 final y. Now remember, from the first diagram after collision, identify what is v1 final. V1 final is this. So it means to find v1 final, this component was cut. It was giving us v1 final x. We had v1 final x is v prime cos 30. But look at this. So v1 final is going to have sine, you get. So v1 prime sine 30. So that means we are going to have negative 2 times v1 prime. Now in the y we have sine 30 for the first ball, remember V1 belongs to the 2 kg ball, equals to 3 times V2 final. Why? V2 final, we are given it's 4 meters, so times 4. Then V2 final, we don't know the angle, sine theta. So we can just now simplify things here. What is sine 30? Sine 30 means 1 over 2, so that is 0.5. If you multiply negative 2 times 0.5, the answer is negative 1 V1 prime, which equals to 3 times 4. We are going to have 12 sine theta. Now that. So here you can get rid of the negative by dividing both sides by negative, also here by negative 1. So that will remain with V1 prime equals to negative 12 sine theta, like that. So this is our second equation. Remember, our goal is to know what is V1 final, the velocity of the first ball after collision, and also the theta or direction for the 3 kg ball. That's our goal. So we have this equation, and also we found the other equation. We found this other equation, so we can solve them simultaneously to find theta and V1. So we have 20 equals to square root of 3 V1 prime plus 12 cos theta. So we have second equation, 20 equals to the square root of 3 V1 prime plus 12 cos theta. So this was our first equation. Now, how are we going to solve this equation? Mean that substitute in this equation where there is V1 prime. So in this equation, we are going to replace where there is V1 prime with negative 12 sine theta. So we are going to have our new equation, 20 equals to square root of 3 times V1 prime, but V1 prime is this. So it's going to give us the square root of 3. It's going to give us negative 12 sine theta plus 12 cos theta. Hope I'm doing it correctly. We have V1 prime. It's going to give us that. So now, if you simplify, we are going to have negative 12. Going to have negative 12 square root of 3 sine theta plus 12 cos theta, like that. So this is what we have after simplifying. So now we can divide throughout by 12. We can divide throughout by 12, also here by 12, also here by 12. So when you simplify, 4 into 20 is going to give us 5. 4 into 12, that is 3, equals to negative 12 over 12, that is negative 1 square root of 3, then sine theta plus 12 over 12, that is 1, so cos plus cos theta. Now let us just rearrange this. So we are going to have cos theta minus the square root of 3 sine theta equals to 5 over 3. That is what we have. So now, remember from trigonometry, this is an identity. This is an identity for r cos theta plus alpha, which equals to this number 5 over 3. So here, this is an identity I've written here. This means this. If you expand, it's going to give you that. So this is trigonometry now. We are doing MA 110, trigonometry, mathematics. This simple, even the G12Z. those doing additional mathematics, ADMA, they are doing this multiple angles. So now here what are we going to do? We need to find R. Now remember, R is found by the square root of the number that is here. What number is here is 1, you square it, plus what number is here? The coefficient of cos square plus the coefficient of sine square. So we have negative the square root of 3 square. That is how you find R. So in this case, R is going to give us 1 plus 3. So R equals to the square root of 1 plus 3. We are going to have 4, and the square root of 4 is what? Is 2. So that means R equals to 2. So that means R equals to 2. So now we can just substitute where is R, we put 2. Remember, our goal is to know theta. You get? Once we know theta, it's very easy for us to find V1 prime. So now here, let's just substitute in there. So we're going to have 2 cos theta plus alpha equals to 5 over 3. 5 over 3. So remember, this was a very lengthy question and challenging question. To solve this one, you must have, you should have some brain. Yeah, you must have some brain. So now, how are we going to solve this? We can multiply both sides by 1 over 2, so that we eliminate, or divide both sides by 2, so that we eliminate the 2. So 2, we are going to remain with cos theta plus alpha equals to 3 times 2, that is 5 over 6. 5 over 6. Now, how do you find this one? We need to find the cos inverse of 5 over 6. So theta plus alpha equals to, what is cos inverse of 5 over 6? So that what is cos inverse of 5 over 6? Cos inverse of 5 over 6. Let me use a calculator from here. Just that I didn't have a calculator. So we have cos inverse of where is it? So cos inverse of 26. I don't have a calculator, so I don't know what we are going to do here. Okay, so what is cos inverse of 26? What is the cos inverse of 5 over 6? Okay, so cos inverse of 5 over 6. Okay, so what is 5 over 6? So 5 divided by 6. So 5 divided by 6, 0.88. So we're having 0.8333 is carrying. So now, what is cos inverse of that? So we're going to have 0.8333. Sorry, I'm using the PC to find that. I left the calculator. So what is cos inverse of that? We're having 33 we're having 33.56 degrees. This is what we are having. So now remember, we can let this one be x. So mean that cos x equals to, excuse me. So our goal is to find theta. So our goal is to find theta. So now theta, you know that 90 minus 30, that is 60. Right? So now meaning that if we can find theta, theta plus 60 equals to 33.56. If you subtract there, we're going to have 33.56 minus 60. So theta equals to, if you do this number minus 60, it's supposed to give us something like 26. Yeah, negative 26.4 degrees. So that is theta. And so this means the 3 kg ball, 3 kg is below negative x-axis. This is what it means. Now, after knowing theta, which is negative 26.4, it's very easy for us to find v1 prime. Then the question is done. So we know that v1 prime equals to negative 12 sine. Now theta in this case we have it's negative 26.4. So if you do on the calculator, let's do this number, the sign of that number. We are having coming calculator. So what is the sine 26? So 26.4 sine 0.44, then this same number times 12 5.0. So v1 prime is giving us 5.334 meters per second. So these are our answers. So theta, we have negative 26.4. The negative, that's showing that it's below the negative x-axis. And v1 prime, we have 5.34 meters per second. So these were our answers. So pay attention to what I did here. Revised trigonometry, otherwise the question was very challenging. As you can see, I've used up 2 pages here. So this question was very challenging. You must go through it.